Okay, so let's look at this problem. It says that the probability the cafeteria will be serving mac and cheese is 52%, and the probability that it will be serving pizza is 72%. The probability that the cafeteria will serve mac and cheese or pizza is 89%. What is the probability that they will serve mac and cheese given that they serve pizza? So the first thing we see is this word here, this phrase, given that. So automatically we know that we are in a conditional probability problem. And what I would do first thing is take the information given and translate it into symbols. So we know, for example, that I'm going to do it up here at the top. The probability of mac and cheese is 52, so that's 0.52. The probability of pizza is 0.72. And then it says mac and cheese or pizza. I'm going to underline the word or. The word or is very important because when we translate it, we have to make sure that we use the union, right? Mac and cheese or pizza is 89%. Okay, so let's take a look at the problem. It says, the problem wants to know what is the probability of mac and cheese given that they serve pizza. Now we know that when you have a conditional probability problem, the sample space is made smaller. So our denominator now, instead of being the sample space, is just the probability of pizza because we're making that assumption. And our numerator is going to be the intersection of mac and cheese and pizza. Now here's the problem. We have the probability of pizza. That's been given to us. But the probability of the intersection is missing in the information that we've been given. So what we need to do is we need to switch and go ahead and use the addition rule for probability in order to find our intersection. So our union rule states that if we know the union, it's going to equal the probability of m plus p minus the intersection. So we have 0.89 is equal to 0.52 plus 0.72 minus x. That's the probability of our intersection. And so when we do the math, we get x is equal to 0.35. So what that means now is that I can go over to my probability up here, my conditional probability, and it's going to be 0.35 divided by 0.72, which gives me 0.4861. Now again, look at the logic. We wanted the conditional probability, we have the denominator, we need the numerator, so we use the addition rule in order to find it. Let's look at the next problem. It says, what is the probability that they serve mac and cheese given that they don't serve pizza? Now remember, if you want to talk about not something, we have p prime. So we want to know the probability of m intersect p prime divided by the probability of p prime. That's how our formula looks. Now, the denominator is easy to find because if the probability of p up here is 72%, then if we subtract that from 1, we will get the probability of p prime. So the probability of p prime is just 28% because remember, whenever you have probabilities, it always needs to add up to 1. So the probability of p plus the probability of p prime will have to equal 1. The problem here really is the numerator. We have no idea what the probability of m intersect p prime is. So we're going to turn to another one of our tools for conditional probability, which is the Venn diagram. So here we go. We're going to draw our Venn diagram. Here is m, here is p. We start always in the middle with the intersection. The intersection is what we just found in the last problem. That's 0.35. If m is 0.52, we're going to subtract the 0.35 so that we get 0.17. Remember, if m is 0.52, that means it's the entire circle, which is why we did the subtraction. And if p is 0.72, that's going to give me 0.37 left here, again, because the entire circle has to add up to 0.72. Last, we're going to fill out the outside piece of our Venn diagram. If the union, everything together is 0.89, meaning we can add up this, this, and this, and we get 0.89. That leaves me with 0.11 out here. So now let's take a look at M intersect P prime. So M intersect P prime is going to be everything that's inside of M, so it's got to be in this circle here, but it's outside of P, which means really we're just talking about this region. So this 0.17 here, that's the stuff that's inside of M, but is not in P. And so that is the numerator that we want. And then when we do our division, we get 0.6071. And that is our final answer. So this is another good example where we are using a Venn diagram in order to answer the problem.